In today's lesson, we'll be learning how to graph quadratics using the x-intercepts. Here are the key concepts for today's lesson. You can go over these on your own. Before we talk about quadratics, let's review our linear relations. And a linear relation is a line when you graph it. A line can be expressed in standard form, ax plus by plus c equals 0, or ax plus by equals c. These are essentially the same thing. The only difference is that the c has been rearranged to the other side of the equal sign. You'll see both of these versions depending on what resource you're using. As well, you can also express a line in slope-intercept form, which is y equals mx plus b. Slope-intercept form is much more useful because you can see the slope of the line as well as the y-intercept. Let's review some of the features of a line. If you select 2 points on this line, such as a point here and a point here, and make yourself a little triangle, that would be the slope. And slope is rise over run, or y2 minus y1 over x2 minus x1. The point at which the line crosses the y-axis is considered the y-intercept. And the point at which it crosses the x-axis is considered the x-intercept. For the coordinate of the x-intercept, the x value will change depending on what type of line you have, but the y-coordinate will always be 0. For the y-intercept, you have the opposite situation, where the x-coordinate will always be 0, and the y-coordinate will change depending on what type of line you have. And that's a really quick review of linear relations. Now let's talk about quadratic relations. A quadratic relation is often referred to as a parabola. So you can say parabola or quadratic relation and people will know what you're talking about. Similarly to a linear relation, a quadratic relation can take on 3 different forms. It can take on standard form, vertex form, and factored form. You're probably most familiar with standard form and factored form. We'll be talking about vertex form later. To get from standard form to factored form, you need to factor, and that's what we've been working on the last couple lessons. Just like a line, there are different features for parabola, and let's talk about them. This point would be considered an x-intercept because that is where the parabola intercepts the x-axis. However, there is another x-intercept on the left, and that is also where the parabola intercepts the x-axis. For our x-intercepts, the y-coordinate will always be 0, while the x-coordinate will change depending on what type of parabola you have. So I'm going to write that on the left side as well. And just like a line, there is also a y-intercept, and that is where the parabola intercepts the y-axis. The x-coordinate is always going to be 0, but the y-coordinate will change depending on what type of parabola you have. And there is a 4th point over here. This is referred to as the vertex. Now, the vertex is located on the axis of symmetry. A parabola is symmetrical, and the axis of symmetry goes through its vertex. And let me label this the axis of symmetry. If you look closely at the x-intercepts, you'll notice that the axis of symmetry goes between them. So if I know the value of this point and that point, I can find this value, and knowing this value, I can substitute it back into the quadratic equation, and I can find the coordinates of my vertex. I'm going to show you how to do that later. As you can see, there are many similarities between a linear relation and a quadratic relation. In our first example, we want to find the x-intercepts and the vertex of y equals x squared plus 8x plus 7. Then we want to sketch its graph. You should notice right away that the quadratic relation is in standard form. And if you recall, standard form isn't very useful. It doesn't tell us very much information about the quadratic relation. Therefore, let's turn it from standard form into factored form. And we're going to do that right now. So let's rewrite the question, y equals x squared plus 8x plus 7. First, you need to ask yourself, is there anything that I can common factor out of these three terms? Is there a greatest common factor here, or is there a variable common between all three terms? The answer is no. So we're going to have to use a technique that we learned in a previous lesson. We want to think of two numbers which add up to 8 and two numbers which multiply together to give me 7. I'm just going to add in the positive signs to emphasize that you really need to pay attention to the signs. So you're going to need to use your times tables and some mental math and guess and check. The numbers you should come up with are positive 1 and positive 7. And those same two numbers would be down below as well. And since the A in this situation, so remember that's A, that's B, and that's C. Since A is equal to 1, we can use a shortcut and go directly to the answer instead of decomposing the center term. So let's go ahead and do that. So this is y equals x plus 1 multiplied by x plus 7. We've just factored our quadratic relation. Now we want to find the x-intercepts. So let's rewrite our factored quadratic relation, which is y equals x plus 1 multiplied by x plus 7. If you recall, the x-intercept has the form of some number and 0, where the y-coordinate is always 0. The x-coordinate will change depending on what type of parabola you have, but y is always 0. Therefore, to find this other coordinate, we are going to say sub y equals 0. So instead of writing y, we're going to write 0, and everything else stays the same. Now this part is a little bit tricky. A lot of students have difficulty here. We have a binomial here multiplying another binomial. We know the answer is 0, which means one of these binomials has to be equal to 0. Either the first binomial is equal to 0 or the second binomial is equal to 0. But one of them has to be 0 in order to get a product of 0. Let's make a little note for ourselves down here. I'm going to say x plus 1 is equal to 0, or x plus 7 is equal to 0. We don't really know. We have two options. Once we do this, let's go ahead and solve for x. I'm not going to write the work in because I'm going to expect you to know how to do this, but in this scenario, x is equal to -1, and here x is equal to -7. This now gives us the x-coordinates of two of our x-intercepts. So let's express these as coordinates. So this x-intercept would be -1, 0, and this x-intercept would be -7, 0. I'm just going to scroll out to show you all the work that was required for this part of the question. Let's mark down our x-intercepts. One of my x-intercepts is over here at -1, 0, And my other x-intercept is over here at -7, 0. I'm just going to write in those coordinates. -1, 0, and this would be -7, 0. Recall from before, the axis of symmetry runs directly between the two x-intercepts. Now, if you were using graph paper, you could kind of visually see where the middle number is between these two x-intercepts, but obviously there is a more mathematical way of doing this. So you would take those two x-coordinates, you would say -7 plus -1, and you would divide them by 2. So -7 plus -1 is -8, and -8 divided by 2 is 4. Therefore, the axis of symmetry is going to run through, oops, I forgot to put a negative sign there, and it's going to run through -4. So I'm going to draw a little line to indicate that is the axis of symmetry. And I'm also going to label this axis of symmetry. Since I know this value to be -4, I can plug it back into the quadratic relation to find the other coordinate, so the y-coordinate of my vertex. Because the vertex lies on the axis of symmetry, that's why we can substitute that value in to find the other coordinate. Now at this point, I'm going to rewrite my quadratic relation, which is y equals x squared plus 8x plus 7. I'm also going to rewrite my factored form, which is y equals x plus 1 multiplied by x plus 7. Using the information from the previous slide, I'm going to sub x equals -4. Now, you can substitute x equals -4 into either the standard form of the quadratic relation or the factored form of the quadratic relation. You will get the same answer. I'm going to do it in the standard form. So I'm going to replace x with a -4, and I'm going to replace the x with a -4 again, and that 7 stays the same. -4 to the power of 2 is 16. Positive 8 multiplied by -4 is -32, and the positive 7 stays exactly the same. Let's just crunch some of these numbers now. So 16 minus 32 plus 7 is -9. Which means we know the value of y and we know the value of x, therefore we can express the vertex as a coordinate. And the vertex is going to have a coordinate of -4, -9. And let's just scroll out to show you all the work that was required for this section. Now that we have our x-intercepts and our vertex, we can go ahead and graph this quadratic relation. So the x-intercept, again, is over here, and the other x-intercept was over there. From these two x-intercept values, we found the axis of symmetry, and we know the vertex lies on the axis of symmetry. We determined it to be -4, 9, which is down here. And with these 3 points, you're going to connect them with a smooth line. And we're going to put some arrows at the end of this parabola to indicate that it's going on and on forever. Before we finish, let's label some of these points. That was -1, 0. This was -7, 0. The vertex was -4, -9. And let's just label that as an x-intercept. That also was an x-intercept. This was the vertex. And I'll just label the axis of symmetry while we're here. As you can see, it passes through the vertex. So I'm going to label this axis of symmetry. And if you really wanted to, you could find the equation of this straight vertical line, and it would be x equals -4.